Guys, welcome to another video. Welcome back to my channel. In today's tutorial, we shall be taking a look at the simultaneous linear and quadratic equation on the board. It's an Olympiad problem, something very interesting and simple. So let's go see the problem and the solution together as usual. So we are given that x plus y is equal to 1 and x squared plus y squared is equal to 2. We have to find x to the 8th plus y to the 8th. As you can see carefully, this is just a linear, simultaneous and quadratic equation. Something very simple. But the only clause is the x to the 8th plus y to the 8th. So I shall present two methods in solving it. The first one is the traditional method. Then we shall make some comparison. And in the second one, I'm going to use, a well-known binomial formula, something very simple and basic. Maybe you shall be the judge to compare which method is simpler and more flexible to understand. Before we delve into the solution, if you are new on this channel, please do well to subscribe and turn on the post notification so that you can be notified anytime I upload a new video. Without any further ado, let's delve into the video proper. So we have here x plus y is equal to 1, x squared plus y squared is equal to 2. This is something we are used to. It's a high school problem. So I will still use the traditional method. We have x plus y equal to 1. I'll call this equation number 1. We have x squared plus y squared equal to 2. I'll call this equation number 2. Then equation 1, I can make a subject formula, either making x be the subject or y the subject. It's a matter of choice. I think this one is called, substitution method in solving simultaneous equation. I would then say from equation 1, we have that x plus y is equal to 1. So this implies that x equal to 1 minus y. I could also call this equation number 3. The next thing is this. I will plug in x equal to 1 minus y into equation number 2. And equation number 2, we have that x squared plus y squared equal to 2. So anywhere I see x, I will substitute 1 minus y. So we will now have 1 minus y squared plus y squared, the static is visible, equal to 2. 1 minus y squared is 1 minus y in parentheses multiply 1 minus y in parentheses. But you could do the expansion directly. So 1 squared is 1, I'll write 1. Then 1 multiply negative y, that will be, 1 multiply negative y is negative y. I'm done with 1. Negative y multiply 1 will also give us negative y. Negative y squared will give us positive y squared. I'll be having y squared plus y squared equal to 2. At the end of the day, if we collect like terms, negative y added to negative y, that will give us negative 2y. I'll be having 1 minus 2y. Here we have y squared plus y squared, which is 2y squared. 2y squared equal to 2. This is a quadratic equation. I will rearrange it to be in a standard form. So I can write this to be 2y squared minus 2y plus 1 equal to 2. Okay, I will take the 2 from the right to the left, so everything will be equal to 0. 2y squared minus 2y plus 1 minus 2 equal to 0. 1 minus 2 is minus 1. So 2y squared minus 2y minus 1 equal to 0. So this is the quadratic equation we are going to be solving. Look at this equation very well. This cannot be factorized. This is not factorable. So we are going to use the quadratic equation formula. And this quadratic equation is in y. Therefore means that y is going to be negative b plus or minus the square root of b squared minus 4ac upon 2a. So this is the quadratic equation formula. The ABC you see in this formula are the constant terms in this equation. A is 2, B is -2, C is -1. So I can then write that y equal to, now that we have b to be negative from the main equation, we also have a negative b in the formula. We'll now be having -2 or -2, which is +2. So we have 2 plus or minus square root 2 squared. I'll put a negative sign there. Then 4 multiply 2, that's 8. Then 8 multiply -1, that would be -8. And we have a negative sign there before. I'll write +8, everything over 2 times 2. 2 squared is 4, 4 plus 8 is 12. I'll write y equal to 2 plus or minus the square root of 12 upon 4. Because of the plus and minus here, we are going to be having 2 answers. But before we go further, we can actually simplify the square root of 12. It's an Olympiad problem. Calculator is not allowed you to, always think outside the box. Square root of 12 is going to be square root of 3 multiplied square root of 4. The choice of 3 and 4 is that when we are expressing radicals, it's always good to look for one of the factors that is a perfect square. That's the best way that you can actually simplify the radical. So I could write this to be 2 plus or minus square root of 3 multiplied the square root of 4 upon 4. Because 4 is a perfect square, the square root will be 2. Then square root of 3, that's irrational, which is actually a radical. So I could write y to be 2 plus or minus, the square root of 4 is 2. I will use 2 to multiply rad 3. That would then be 2 rad 3 upon 4. Don't worry, 2 rad 3 upon 4. I'll take this part of the board off. Now, the essence why I'm using this first method is because we are used to it. Whether this method will be feasible in solving Olympiad problem, I can't tell, but you will do at the end of the video lesson. So the first answer, I'll call that y1. y1 is going to be 2 plus 2 rad 3 upon 4. y2 is going to be 2 minus 2 rad 3, 2 rad 3 upon 4. Because we have 2 on the numerator and 4 is also an even number, we could use 2 to divide every number on the numerator and denominator. So that's going to give us y1 equal to 2 divided 2 is 1. 2 divided 2 rad 3, 2 cancel out, we have 1 plus rad 3 upon 2. 2 divided 4 is 2. Then y2 will not be 2 divided 2, that will also be 1. Then negative 2 rad 3 divided by 2, okay, negative rad 3, 2 divided 4, that will be 2. So we have y1 and y2. The reason why I'm designating this y1 and this y2 is that because of the nature of this problem, linear and quadratic simultaneous equation, we are going to have 4 answers. In most cases, the answer is written in pair or coordinates, x1, y1, x2, y2. So I'm going to use only y1. Mind you, our goal is to be able to express x to the 8 plus y to the 8. So now using y1, I will say x1 equal to 1 minus y1. So this is the first coordinate. So the subscript 1 is just to designate the first. as the case may be. So, and y, I'm using y1, it will now be 1 minus 1 plus 3 upon 2. Okay, everything here is in the parentheses. So this is going to be, S1 will be 2 multiply 1, which is 2, 1 plus 3, everything upon 2. Okay. If I open this parenthesis with the negative sign, it's going to give me 2 minus 1 minus 3, everything upon 2 is equal to 1 minus 3 upon 2. So this is the value of x1. So I shall use these first values to compute x to the 8 plus y to the 8. So therefore, x to the 8 plus y to the 8 is going to be 1 minus 3 upon 2 to the power of 8. Write this 8 very well. Plus y to the 8. Well, where is y1? Okay, that's 1 plus 3 upon 2 to the 8. So you can see the enormous task that we need to, overcome here. So, except you have an IQ like that of Einstein, the rest, you are not going to do this in an Olympiad examination and survive it. So, you can only do this by using Pascal triangle or binomial expansion, and that's going to take time unless you use a calculator. Regardless, whoever is able to solve this, immediately this video is posted, you are going to be rewarded by one of my finest students who is pursuing his PhD, chemical engineering at Airborne University in Montgomery. So I shall use the alternate method. I will take this part of the board off. Okay, I'm stuck. It's not difficult, but you only take time. All you just need to do is to separate the half. When you now have 1 minus 3 to the 8, 1 plus 3 to the 8, you use Pascal coefficients, do the expansion and collect like terms, then you get the answer. But the alternate approach is quite interesting. We are used to this well-known binomial formula, a plus b all squared. This is called the square of sum. And this is equal to a squared plus b squared plus 2ab. A squared plus b squared is the sum of squares. So therefore, I'll start with s plus y all squared. This is going to give me, just to fix everything to the formula there, this is going to give me s squared plus y squared plus 2sy. Okay? And s plus y all squared and s plus y is equal to 1. So this is 1 squared equal to s squared plus y squared. That's the second equation. That's going to be 2 plus 2sy. I can write this to be 2sy plus 2 equal to 1. If I take 2 to the right or subtract 2 from both sides, 2sy will be equal to negative 1. So sy will be negative half. We need this for our further work. Then I have started with s plus y all squared. I could move to the next even power. So s squared plus y squared all squared. So you can see the beauty and creativity we are putting in this alternate method. This is what Olympiad mathematics require: critical thinking, logical reasoning, and being able to think outside the box. So if I actually take care of this using this formula, I'll be having s squared to the second, s squared squared. That will be s to the fourth. Then I have y squared squared. That will be y to the fourth. Here we are going to be having 2s squared y squared. Okay, s squared and y squared, okay, they have the same powers. We can actually write them to be s to the fourth plus y to the fourth plus 2sy squared. If I isolate s to the fourth plus y to the fourth, I'm going to be having s to the fourth plus y to the fourth. I will take this s squared plus y squared all squared and minus 2sy all squared. Now, s squared plus y squared is the second equation, which is 2 squared. xy is negative half. So we can now evaluate s to the fourth plus y to the fourth to be 2 squared minus 2 into negative half squared. Square is 4. Negative half squared is 1 upon 4. 2 into 1 upon 4. Okay. 4 minus, okay. 2 can divide 4 to give 2. We are going to be having s to the fourth plus y to the fourth equal to 4 minus half. We put this as a fraction. It's going to be 8 minus 1 upon 2. And that will be 7 upon 2. So this is s to the fourth plus y to the fourth. Some persons have already seen the answer, calling, knocking. So we moved from x to x squared. We now move to s to the fourth squared. Look at the pattern. Very interesting. S plus y all squared, s squared plus y all squared. Then we'll now go to s to the fourth plus y to the fourth all squared. So similarly, s to the fourth plus y to the fourth all squared, that's going to be s to the fourth raised to, okay, s to the fourth squared, or s to the fourth raised to the power of 2. That would be s to the 8th, y to the 8th as well, the same thing. Then plus 2s to the fourth, y to the fourth. So this implies that s to the fourth plus y to the fourth all squared, this could be written as s to the 8th plus y to the 8th, let me write this properly, plus 2xy raised to the fourth. Now, I can isolate x to the 8th plus y to the 8th. You are seeing the beauty in this. So I'll have s to the 8th plus y to the 8th isolated. It's going to be s to the 4th plus y to the 4th all squared minus 2sy raised to the 4th. Yeah. Now, x to the 4th plus y to the 4th is 7 upon 2. 7 upon 2 squared minus xy is negative half. All right, 2 into negative half to the 4th. Negative half to the 4th is negative half multiply itself 4 times. One pair will be positive, the other pair positive. So 1 over 4 plus 1 over 4 multiply 1 over 4, that will be 1 over 16. So we are going to be having here 7 squared is 49, 2 squared is 4. Here we are going to be having 2 into 1 upon 16. It's going to give us 49 upon 4 minus 2 divided 16, that will be 8. 1 upon 8. So I want to make the denominator of this fraction to be 8. I need to then multiply the numerator and denominator here by 2. This is something as 98 upon 8 minus 1 upon 8. Because the denominators here are the same, I can simply subtract the numerators. We will be having x to the 8, therefore x to the 8 plus y to the 8 is going to give us 97 upon 8. So this is the final answer. So as you can see, you are the judge to compare which method is the best, either this or that, I don't know, but as far as Olympiad is concerned, the best method should be the second approach. So give this video a thumbs up, like it, share it with your friends and colleagues. See you next time. God bless.